All right, everybody, welcome to the business of open source. That is the track that we're in this room for this afternoon. And this session is Easy Map Apps with React. Ducky from GeoMoose.
Yay, hey folks. In coming up with this presentation, I really did try to hit at something as clickbaity as possible. I have React, I have OpenLayers, and I have Easy, which is something that almost never happens. But I was also pretty lucky in that I was able to name the presentation the product. So while this might be the business of open source, really this is about an NPM package that's available for you right now. So who is behind @PlanetMaps? For folks familiar with the JavaScript ecosystem, you'll see that it starts with @Planet. This is something that was started while I was at Planet Labs. So hi, I'm Duck. I'm formerly a staff engineer at Planet, working on some of our front-end technologies. I'm currently the VP of engineering at a startup called Geospatial. I'm a sometime contributor to OpenLayers. I'm the primary author behind the GeoMoose WebGIS client product, and I've kind of been sprinkled into a lot of different parts of the open source ecosystem throughout the years. My partner in crime for this, who also has a much better LinkedIn picture than I do, is Tim Schaub. He's significantly more famous than me as the primary maintainer of OpenLayers and is a principal engineer at Planet Labs. So what is it? Well, it's mapping for React. It's based on OpenLayers, and it's declarative. So folks who are familiar with React understand that it's a very declarative framework. You know, they have the JSX, and you build small components into larger ones, into applications, and it's all very nice and composable. However, none of the mapping libraries that we use on a regular basis are including OpenLayers. They're all imperative. So the idea behind PlanetMaps is, hey, let's try and make this declarative. One of the reasons why you might be asking is why do this, other than to try and make things pretty and work nicely with React, is JavaScript mapping libraries can be very hard to approach. I think there's a trope in the community that what you do is you start with Leaflet because it's easy and because OpenLayers looks hard, or if you want something that's pretty and fast, you go to MapLibre or Mapbox, and if you want to put a bunch of stuff together, you go to DeckGL. So there's a large variety in offerings for web browser-based mapping libraries right now, but like, to a lot of my junior developers coming fresh out of uni, they were all completely indecipherable. However, most folks have had at least some exposure to React. So if you want to compare your favorite mapping library and feel terrible about its popularity in the wild, compare it to the statistics for the use of React. Combined OpenLayers, Leaflet, and the various Mapbox GLGSs don't even touch the Richter scale of like Stack Overflow questions in comparison to React. So if I'm looking at training somebody up and I'm looking at introducing them to something new, I want something that looks like React to avoid some of that confusion. So then the next question that I seem to get this over the years all the time is why base this on OpenLayers? Well, as Tim and I are both contributors to OpenLayers, this is the library with which we had the most familiarity. We knew that we could make OpenLayers do what we want. And if there were things that we needed to change in OpenLayers, we would have some insight and availability to do so. We also already had a large code base in OpenLayers. In fact, we had multiple large code bases already written in OpenLayers. Momentum is a hell of a drug. So we did not really want to abandon some of the custom code that we'd already done. We wanted to adapt it. Speaking of that custom code, I think one of the real strengths of OpenLayers, just generally, like if you walk away not wanting to use PlanetMaps, but if I can sell you on OpenLayers a little bit more, it's that it is really good at doing some of the in-browser raster processing. And I really feel like it has unique capabilities in that over some of the other libraries. And Planet Labs, big satellite company, we have lots of raster data that we're hucking around. So those capabilities were really important to us when making that decision. Now, everyone in this room, I am sure, has at least tried to approach doing OpenLayers in React. Because frankly, what I love about this conference is just about everyone that comes here is a genius, really. You've approached a really weird community and a really weird problem set and thought, that's cool, I want to dig in. So when it comes to writing code, you're going to go, Duck, I have this code written already. I'm going to use a ref, I'm going to use an effect, I'm going to get it working. Everyone that I've ever talked to who's done mapping applications in React has written some version of this code, and it sucks. The reasons why it sucks are multiple. So first, it's using a ref. Now, the refs have existed in React since version 1.0, essentially, because there needed to be some sort of escape hatch for getting back at the DOM. This is where we're going to get into like a technical derailing, so please, folks, buckle up. So using refs actually takes a value and puts it out of the React lifecycle. And in fact, you can even find older quotes of Dan Abram, one of the primary authors of React, saying, refs were a terrible idea, but we needed them, and we will continue to have them. And in this particular case, one of the things that'll happen is, for those who are somewhat more familiar with using functional components and hooks, is this will create an OpenLayers map. It'll render it. This is the hello world problem of OpenLayers maps, right? You're going to get an OSM layer in a map. But if that div reference changes because it's been reorganized in the DOM, or it's been like resized, or another toolkit has done away with it, your map goes away. And so then you get to spend the next 2 hours figuring exactly how to make that effect dependency array correct and how to make sure that that lifecycle happens so that you don't have that flashing issue anymore. And as is the case, the more effects you have, the more problems that you have. Both new and old React developers can struggle with hooks. Like, this is pretty well documented. It did not take me a lot of Google bashing to find a number of Medium posts, Stack Overflow posts that were all like, man, hooks really suck. How can I make this less painful? And then the next thing you run into is having to compose hooks, right? Because like all this did was make the map. It doesn't do any interactions. It's not pulling in any real data. And so you're going to need more hooks that have more dependencies. And then they get chained together. And then you run into issues with React versions changing the orders in which hooks can actually execute. So folks who haven't been burned by that yet, you may someday find yourself that way. Now, one of the other follow-ups is, well, what about Leaflet or Mapbox.gl in terms of fixing this problem? I have terrible news for you. Even the official Mapbox.gl JS tutorials for React integration has essentially this code in it. Cross out OpenLayers, put in MapLibre or Mapbox.gl, and it's the same code. So we had some inspiration. As of React 16, React uses what they call fibers to do their rendering. This was done so that they could unify a lot of the code base between React DOM and the React native. So kind of the core engine that makes a lot of the determinations of what happens is now all the same in React for those two different types of hydration cycles, and they call that a fiber. The other bit of inspiration that I had personally is I'm lucky. I have a kid who likes to try and make things in 3D to impress his friends. And so I learned a little bit of 3JS and found out that that has a declarative wrapper. Again, a really great 3D library. Doesn't do a lot with mapping, but they had a fiber so you could do declarative stuff in 3JS. Plus, digging in, found two other pre-existing OpenLayers fibers. That was pretty exciting. And then finally, as I was getting to know Deck.jl and evaluate some of that work, it has a nice set of React components, which kind of also hinted that we were within the world of the possible. But why didn't those work? Ultimately, like as a developer with a job, like you don't want to rewrite a whole bunch of code for fun, right? Like you want to be productive. So why didn't these work? We found that the two other OpenLayers fibers essentially brought in all of OpenLayers all of the time. So whereas a Hello World example that we were putting together was, say, 60 kilobytes, using the fibers we were seeing it hit a megabyte. And while it might seem silly in this day and age where we talk about petabytes and terabytes, still when you're serving a web application and it's going to have thousands of downloads a day, these things start having an impact. And if not an impact on your actual cost, an impact on your users and how responsive the app feels, how it loads, things like that. The other problem we found with the two existing OpenLayers fibers were that they were hand-coded. Like someone sat there and actually wrote line by line ways of porting OpenLayers into React, and that just looked painful and unmaintainable over time. And finally, for folks who have played around with DecGL, it doesn't really wrap all of a mapping application, right? It's a great composition tool, but it doesn't stand on its own. So we needed more than what any of these were going to provide. So TLDR, we're going to write some code. But we had a few really strict design ideals when we went to do the project. I kind of wish we would have documented these a little bit more, and they are actually in our README now, but because I think a good lesson learned is whenever you're doing a new open source project, having your design ideals written down helps guide new developers in your project for what you're looking for. I also think it's good when you get in a drive-by pull request and an angry person who thinks they're really contributing to your project, but it doesn't actually make sense to be like, hey, we have these design ideas. We're sorry, but we're not looking for this. But for this project, we had a few. One is, we just wanted React and OpenLayers as the dependencies, nothing that actually stitched together. As anyone who's played with NPM knows, any extra dependency could come with 10x extra dependencies, of which there are 10x extra dependencies. So keeping to a strict dependency service was really important to us. We wanted to make it scriptable. So OpenLayers, because it's really well structured, is actually really easy to introspect. And so we wanted to be able to use that introspection to automatically create the components that would then be in React. We didn't want to impact performance. Making things slower is making things bad, so we didn't want to do that. And as much as I just spent a chunk of time negatively talking about refs, we still wanted the escape hatch to get at the OpenLayers classes for bespoke behavior. So we wanted to make sure that any component that we had would support that through the ref prop. All right. This is what the GIS web application Hello World looks like in Planet Maps. It's a lot cleaner. There is the map component that gets brought in, and then you define a view, the tile layer, and OSM. But there's no hooks, there's no refs. Everything plays nicely in the React lifecycle, so you're not having to worry about things getting loaded and unloaded. And it's really easy to read. This is something that's really, really approachable for someone who might be a GIS newbie and playing around in the browser for the first time. We also have the ability to work with React State. So we have this example up on the project's page, and it's using the Natural Earth urban areas dataset along with the Natural Earth continent polygon. And this is going to be really hard to read, I apologize. But at the very top of the code, it's actually just using React's basic use state hook. So just like any other React component, you can define the hook and give it a value. And inside of the layer definition, we actually have the ability to use that value to change the color of what those polygons would be. This seems, the thing I love about this demo is it actually feels really dumb and really easy, and that's the best demo for meaning I solved a problem. Changing an OpenLayers style class in React right now would take you 3 more files and a good set of prayers to make sure it happens consistently. But towards the bottom of the code, you can see that we just have those 2 buttons. There's a gray and a red button, and then the code just will react appropriately. All right, but you're saying duck. These are great Hello World examples. I've written these before. I've written them in every single mapping library I've ever used. Is there something more impressive? Well, I think so. So we ported Planet's Explorer application to the Planet maps. For those folks not familiar with the Planet application ecosystem, this is essentially our primary catalog and our first introductory product for all of our users. So this is, depending on what you've purchased from Planet, the way you access all of your data. It serves every one of our users every day, and again, provides that primary portal. It is an application that is fairly complex. And one of the issues we found, as I was mentioning earlier, like anytime a bug came in that was mapping related, it always got assigned to me because no one else wanted to touch the OpenLayers code. Now, for any sort of organization, that's not a sustainable way to exist, right? Like if you only have one person that's significantly trained up on what we would consider these specialty libraries. So how did it go when we ported Planet Explorer over? Well, there was a negligible impact on performance. In fact, we were able to sort of do the Pepsi challenge on this, and no one could really tell the difference visually or in terms of performance. However, because of all of the complicated React code we had, a mixture of classes and hooks and some Redux reducers, collapsing this down using Planet Maps allowed us to remove roughly 1,000 lines of code. That's, I think, pretty cool, whenever you can get rid of code from a project. And it allowed us to break up the map into subcomponents. So we had some files that were, say, 2,500 lines long because they all needed the right amount of context inside of the various classes and the various components in order to be there. And so it made it very hard to break up. And more importantly, I actually just thought it was fun to do. Like the code was more fun to write and more aesthetically pleasing. And in fact, when I handed over a large chunk of the project to a coworker, she also went, oh yeah, this is way more fun to work with and way easier. So how do you get some? That's the obligatory QR code to get at the GitHub repo. It's available to install on your favorite project using NPM. And we have some live examples up that show off how to do some of the basics. Ready and raring to go. All right. Thank you, folks.